Okay, this page, if at all possible, you guys need to print this paper out. You may be able to write on it on a PDF, but the best way to do this page is to print it out because it's a little bit awkward to do this. What I want to point out is this box right over here. Okay, so here's the key with balancing nuclear equations. The total mass on the left side of the equation has to equal the total mass on the right side. The total atomic numbers on the left have to equal the total atomic numbers on the right. And then here are what your particles look like right here. Remember these particles right here? This is what they're going to look like. There is another way to write the beta particle, and that can also be written with a little lowercase letter e with a -1 and a 0. Sometimes you'll see it written like that too. So let's just do number 1. So when we see this, the total mass, remember the top number is the mass and the bottom number is the atomic number, right? So here's your divider. The arrow is always the divider. That means everything on this side has to equal 218 on top, and everything on this side has to equal whatever francium is. So when I look here, francium has an atomic number of 87. 87. So right here, this number is 87. That means when I add these bottom numbers up, they have to equal 87. Well, the first thing is the alpha particle. And the alpha particle has a 4 on top and a 2 on bottom. 4, 2. So 2 plus what equals 87? Oh, well, hey, that's 85. 85 plus 2 is equal to 87. What element is number 85? Well, when we look at this, here's 87, so if we go backwards, astatine is number 85. So this element has to be AT. But we don't know what the average mass number is. We can look on our periodic table and say, well, you know, it's somewhere iffy around 210, but we need to know not the average, we need to know the actual. So that means these top numbers up here have to add up to 218. So 214 plus 4 is 218. So this top number is 214. 214. So if you look again, 214 plus 4 is 218. 85 plus 2 is 87. That's how you balance them. Really simple, straightforward. It's actually much easier than balancing regular chemical reactions. So let's look at, let's look at number 8. Okay, number 8. So I have 210 on top, 82 on bottom. So the first thing I want to do is, what's element number 82? Well, 82 is lead. So I have Pb, lead. And if you look here, 83, and it's a -1. 83 plus -1 or 83 minus 1, sure enough, is 82. So our bottom numbers add up. But I've got a 0 on top and a -1 on bottom. Which piece is this? Oh, that would be the beta particle. So this lead is going to go through radioactive decay, and it's going to spit out some beta particles. Now, it's going to make beta particles, and it's going to change. It's no longer lead anymore. It's going to change into bismuth. Bismuth has an 83 as an atomic number, so we have 83 here for bismuth, but we need to know the mass number. 0 plus what is 210? Oh, hey, it's 210. So this goes through beta decay. That's what they call it, beta decay. And if you remember on your notes, I told you that it's when a neutron splits into a proton and an electron. Well, look at this. One neutron split apart into 2 pieces. A proton, so now we have 83 protons, and an electron that it spat out. Well, we've got one more proton, but one less neutron, so our mass stays the same. It's kind of cool like that. If it goes through beta decay, this is what it looks like. Look at number 5. Look at this piece right here. We have a 4 and a 2. If we come over here in the box and look at that, oh my gosh, that's alpha decay. It's an alpha particle, so we have alpha decay. So if we look at this, we have Am. So when we look for americium, americium has an atomic number of 95. So we have 95. And our numbers on the bottom then have to equal 95. 2 plus what is 95? Oh, hey, that'd be 93. So what element is number 93? Well, let's see. Neptunium. Right here, number 93. So NP. And then we can say, okay, 4 plus what is 241? So let's say 237 plus 4 is 241. So our numbers on top are equal on each side. Our numbers on bottom are equal on each side. It can get a little more complex if you look at number 12. Just like on chemical equations, we can actually have coefficients in the big side here. So let's do this one. Pick out the particles that you know. In this case, we've got 1 and a 0. Where are we? 1 and a 0. Notice it's not 0 on top and 1 on bottom. That's not a beta particle, is it? So 1 and a 0. So when you look up here, 1 and 0, oh look, there it is right here. It's a neutron. Now we're not decaying in this sense. We're adding a neutron to something. Do you see that? So it's not decay. Decay would be like a decomposition. Decompose, decay would be like a decomposition reaction. That's not what we have going on over here. So we don't know anything about this one yet, but let's look on the other side. We have atomic number 58. So when we look up here, let's see number 58 is cerium, Ce. And then we have strontium. Strontium is number 38. And then we have the neutron piece. And we go back up here, it's 1 on top, 0 on bottom. And there are 6 of them. So 6 times 1 is 6, so we've got 6 of these puppies. How many beta particles do we have? Well, we have 2 of them. And the beta particle is 0 on top, negative 1 on bottom. So 0 and negative 1. That means 2 times this, so we have negative 2 here. We have 0 here. 2 times 0 is 0. 6 times 1 is 6. So when we add these numbers up across the top, we have to incorporate that in here. So now we've got 58 plus 38, y, minus 2. So let's see, that makes this 36. So 58 and 36. What is that, 94? Okay, you guys get a calculator out and do that and make sure and check me on that. I'm looking at 94. You guys might check me though, okay? So let's put 94 over here. And then on top, I've got 144 plus 6, right? That makes 150. Plus 90 is 240, is that right? Again, you guys check me on my math. I'm not stopping to get a calculator. It's... Check me, trust me people, check me on my math. When I do math in my head, things go bad. So my problem here is, though, did I take this into account? So 240 plus 1 is 241, so this makes this 239. Oh my God, go outside. Number 94 is plutonium. Okay, so it can get a little bit more complex. The vast majority of those are pretty straightforward though.